Hello again, and welcome to another CXC math discussion. Today we will be looking at linear inequations, graphing them, identifying the boundaries, and identifying the regions from the graph. So these are terminology and concepts that we will have to apply when we try to solve problems in linear programming. So let's just get to it and identify the first point. What we notice is that we have drawn a line at y is equal to 3. That's a line parallel to the x-axis, y equal to 3. And what we're going to be doing is to identify an area below this line, and we will define this area below this line as a region. So everything below this line is a region, and that region is defined by the inequation y is less than or equal to 3. Naturally, if we extend that argument, everything above the line would also be another region, but that region would now be defined by the inequation y is greater than or equal to 3. So what we notice then is that the line y equal 3, a single line, is the boundary of those two regions. Let us extend that argument by superimposing another line on this graph. The equation for this line is y is equal to x. Now what we note based on our earlier discussion is that the line y equal x is also another boundary dividing two regions. The first region being everything below that line, and that is described by the inequation y is less than or equal to x. And of course, everything above the line y equal x is another region and defined by the inequation y is greater than or equal to x. So what we noticed is that above the line is greater than or equal to, and below the line is typically less than or equal to. Let us identify from this graph a few other distinct regions. There's more information from this graph that we can extract. So let us identify 4 separate regions and use the information we have to describe these regions. If we look at region number 1, we will notice that that region is above the line y is equal to 3 and is also above the line y is equal to x. So where those two intersect or where they overlap can be described by the inequation of y is greater than or equal to 3 and y is greater than or equal to x. So that shaded area shown, region number 1, is y is greater than or equal to 3 and y is greater than or equal to x. That's simply an overlapping region, or if you like, an intersecting region for those two equations. If we look at region number 2, we notice that it is above the line y is equal to 3, but it's below the line y is equal to x. So we can describe it as we did for region number 1. We look again for region number 3, and it's the same approach. We note that region number 3 is below the line y is equal to 3, and it is also below the line y is equal to x. So where those two regions overlap is describing the region identified by number 3 on our graph. Similarly for region number 4, we note that region number 4 is below the line y is equal to 3, but it is above the line y is equal to x. That is simply how we arrive at an overlapping region and boundaries. We will be applying some of these concepts in our next exercise. So let's just get to it. On this slide, we will be looking at sketching a graph of a linear equation. So in our example, we are being asked to sketch the region identified by the inequation 3x plus 4y is less than or equal to 12. Now, in order to sketch or identify the region, we first need to identify the boundary of that region. We do this by simply replacing our less than or equal to sign with an equal sign identifies the boundary. So we are going to draw a straight line for the equation 3x plus 4y is equal to 12. A simple way of doing this is to recognize that for a straight line, we merely need 2 points along that line. Then we connect those 2 points to get our straight line. So in order to get our first point or first coordinate, we can set one of the variables to 0 and solve for the other one. So in the first instance, let us set x to 0 and solve for y. So we get 0 plus 4y is equal to 12, so y is equal to 3, giving our first point as 0, 3, the y-axis. We continue in a similar way to get the second point. So we set y to 0 and solve for x. In this case, we have 3x plus 0 is equal to 12, so x is equal to 4, giving our second point as 4, 0. We simply then go ahead and draw a straight line through those points, and that line, as we said earlier, will be the boundary of the region of interest. Now, to shade the region, we simply look at our equation and recognize that we are being asked to shade that region which is less than or equal to 12. And that is the region below the line, 3x plus y is equal to 12. And this is typically how this is done. Very simple problem, just enough to get us started. We'll be applying some more of these principles. So let's just get to it. Okay, based on what we learned earlier, we are now ready to draw a graph using 4 equations and identify the area that is common all those equations. So we are going to be drawing 4 separate regions. We are going to be looking for a region that is common, or that one region that overlaps all 4 equations. So let us proceed to draw equations 1 and 2, where we have x is greater than or equal to 0 and y is greater than or equal to 0. This is merely identifying an area in the first quadrant where both x and y are positive. X greater than or equal to 0 is saying x must be positive. Similarly for y. So we are operating in the first quadrant. So whenever you see x greater than or equal to 0 or y greater than or equal to 0, we are merely identifying that our region of interest will lie in the first quadrant. So we can now look at equation number 3, and we do as we did previously. We identify 2 points along that line. We sketch a straight line that connects the 2 points and identify the region as the area below the line, because it's less than or equal to the sign that we're working with. Similarly for in equation number 4, we identify 2 points along that line by setting one variable to 0, and by getting our 2 points, we draw a straight line connecting those 2 points, and the region below that line again will be our region of interest. So we now have 4 regions identified on this graph. If we note carefully, there is one particular area on this graph that is the common region for all 4 inequations. That's where all the different regions overlap, and that is identified here as our common region. Very important concept. We will be using this when we solve problems in linear programming. See you next time.